आज आपण शेवटच्या ब्लड सेलकडे जाणार आहोत आणि ती म्हणजे प्लेटलेट और थ्रोम्बोसाइट. तत्पूर्वी आपण मागे पूर्ण केलेल्या RBC आणि WBC यांच्या व्हिडिओ तुम्हाला पोचलाच असेल, त्याच्या नोट्सही तुम्हाला मिळालेल्या असतील, तर त्या रीराईट करा आणि त्याचा स्टडी करा. ओके, so we'll start with the last type of blood cell, and that is known as platelet or thrombocyte. Again we will go by the same way, considering the points such as total number, size, shape, formation, lifespan, destruction, functions and conditions, along with the diagram of blood smear. Now platelets, its total number is about 2.5 to 4.5 lakhs per cubic mm of blood. Per cubic mm of blood. So now you are clear cut. The RBCs are found in millions. That means 5.2 to 5.8 million per cubic mm of blood in male. Then WBCs are found in thousands. That means 5,000 to 11,000 per cubic mm of blood. And now these platelets, these are 2.5 to 4.5 lakh per minute per millimeter or per cubic mm of blood. So that is the difference in the total number of these three types of blood cells. That means RBCs are present in millions, WBCs are present in thousands, and platelets are present in lakhs. So remember that difference. Then we go to the size or shape. These are very small oval shaped. Small oval shaped. You can see in the diagram also. These are very small and oval shaped cells, fragment or cell fragment, you can say also cell fragment without nucleus. Without nucleus. Right? Now why we said that the cell fragment? Now that will be seen under the point formation. So thrombocytes are very small oval shaped cell fragments without nucleus. Then the formation of thrombocyte is known as thrombopoiesis. Thrombopoiesis. Again remember this word. Thrombo means thrombocyte and poiesis means formation or generation. So formation of thrombocyte is known as thrombopoiesis. Now this thrombopoiesis is formed by, or thrombocytes are formed by cellular fragments of large cells. Formed by cellular fragments of large cells known as megakaryotype. Megakaryotype. Now there are megakaryotype. Mega means large. Karyotype means, karyon means nucleus. The cells which are having large nucleus are known as megakaryotype, and these megakaryotypes are present in bone marrow. They fragments, that means they are broken down into smaller and smaller pieces to form these thrombocytes. That's why that is known as thrombopoiesis. Then lifespan. Lifespan is about 5 to 10 days. 5 to 10 days. 5 to 10 days. Remember, after which they are destructed. They are destroyed at the site of injury or in liver and spleen. At the site of injury and liver and spleen. Remember. That means functionally these are helpful in blood coagulation. So, if there is an injury may happens, maybe internally or externally, at that time, at the site of injury, they are destructed. Or after 5 to 10 days, they send to liver or spleen and they are broken down, and that means they are destructed. Then functionally, they secrete the factors. The first function is secrete factors essential for blood clotting. For your information, there are 12 factors are present for blood coagulation, right from 1st to 12. These factors are specifically released by these thrombocytes. Clear? Then another function is they seal ruptured blood vessels by formation of platelet plug. Second function is seal ruptured blood vessels internally by platelet plug, by secreting platelet plug, because internally blood vessels may damage and that rupture of a blood vessel is sealed by secreting platelet plug by this thrombocytes. Clear? And the third function is they secrete serotonin. Secrete serotonin, that is local vasoconstrictor. Now what is meant by vasoconstrictor? Vaso means blood vessel. Constrictor means to contract. So blood vessels are contracted to increase blood pressure, and that function, that means vasoconstriction to increase blood pressure, was carried out by this serotonin component present in the blood, and that is secreted by these thrombocytes. So overall 3 functions are there. They secrete factors for blood clotting, seal ruptured blood vessels by forming platelet plug, and secrete serotonin, that is local vasoconstrictor. Then conditions similar like that of RBC and WBC. Thrombocytosis means increase in number of platelets, that is known as thrombocytosis. Now you are clear cut. When we apply cytosis word to any kind of blood cell, that means there is an increase in number of platelets than the normal value, that means beyond 2.5 to 4.5 lakh per cubic mm of blood. Then thrombocytopenia means decrease in number of platelets below the normal value. That means below 2.5 to 4.5 lakhs per cubic mm of blood. Now you are clear cut. When you add the word cytopenia to any kind of blood cell, then that means there is a decrease in number of that particular type of blood vessel. Then These also causes, this decrease causes internal bleeding, that is called as hemorrhage. Maybe if these blood vessels decrease in a total number, then internally blood vessels may break and the bleeding occur. That condition is known as hemorrhage. Right? So remember this condition, hemorrhage. Okay? Now in this figure you can see the blood smear. There are many, because present in millions, the RBCs are shown. Very small, circular, biconcave, disc shaped. Then WBCs are larger in size, irregular, amoeboid. And their number is few. That means 5,000 to 11,000 per cubic mm of blood. So only 2 WBCs are shown in this blood smear. And the platelets, these are very small oval shaped non-nucleated cell fragments. They are shown in this blood smear and they are present in lakhs. Clear? For your additional information, the ratio of RBC as to WBC is about 600:1. That means in blood smear, if you are counting 600 RBCs, in the group of 600 RBC, you will get only one type of WBC. Any kind, because there are 5 types of WBC. So one WBC is present in the group of 600 RBC. Right? So here we complete the platelet or thrombocyte, under which we have studied total number 2.5 to 4.5 lakh per cubic mm of blood. Size shape, very small, oval shaped cell fragments without nucleus. Formation is known as thrombopoiesis because formed by cellular fragments of large cells known as megakaryotypes present in bone marrow. Destruction at the site of injury or in liver and spleen. Function: secrete factors for blood clotting. Seal ruptured blood vessels by forming platelet plug. Secrete serotonin, that is local vasoconstrictor, to increase blood pressure. And the two conditions, that is thrombocytosis means increase in number of platelets. Thrombocytopenia means decrease in number of platelets beyond the normal values respectively. And decrease in number of platelets causes internal bleeding known as hemorrhage. Clear? So that is about the blood platelets. Now we go to the next point, and that is blood coagulation or blood clotting. Blood coagulation or blood clotting. Clear? Blood coagulation. Just we have studied thrombocyte. So related to thrombocyte, now we cover blood coagulation or clotting. Now what is meant by blood coagulation or clotting? Say, the conversion of liquid blood into semi-solid jelly-like. Conversion of liquid blood into semi-solid jelly-like substance is known as blood coagulation, or substance, or you can say blood also, right? So blood is liquid form, fluid connective tissue containing plasma and three kinds of blood cells. Just we have complete all the components of blood, plasma as well as blood cells. And the next unit is blood coagulation. So now you are clear cut. The conversion of this liquid blood into semi-solid jelly-like blood or substance, that is known as blood coagulation. Now, which are the steps involved? Steps involved in blood coagulation. What happens? Now, actually, this process starts by contact of blood with any foreign substance. Starts with contact of blood with any foreign substance. Any foreign substance or surface, you can say. Not substance, you can say surface, and that is maybe extrinsic, or intrinsic. That means the injury or any foreign substance, when comes in contact with blood internally inside the body or maybe externally outside the body. Both these intrinsic and extrinsic processes involve various clotting factors. Both intrinsic and extrinsic processes involves factors. Just we have studied that factors are released by thrombocytes, and these factors, they are responsible for blood clotting process. Now these clotting factors are released step by step or by cascade method. That means one after another these factors are released, and overall these are 12. That means factor 1st to factor 12th. Always these are indicated in Roman lipi, 1st to 12th. Only factor 6th is not involved in, or it is not in active use. Factor 6 is not in active use. Otherwise, all factors right from 1st to 12th, they are responsible for blood coagulation process. Right? Now, interaction of these factors leads to formation of enzyme thrombin. Now, all these interaction of these form enzyme thrombin. Right? After formation of enzyme thrombin, thromboplastin This is the substance present in platelets. So from platelets, the substance present in platelets, so thromboplastin is released by platelets, help in formation of prothrombinase enzyme. Help in formation of enzyme prothrombinase. Remember, so interactions of all these factor release thrombin, actually this is a substance, enzyme or substance, and thromboplastin from platelets help in formation of enzyme prothrombinase. This prothrombinase inactivates heparin. What is heparin? Heparin is anticoagulant present in our blood. Do not allow clotting of blood when blood is circulating. So, first of all, this heparin should be inactivated. So, heparin is inactivated and convert inactive prothrombin into active thrombin. So, first step is prothrombin. This is one of the components for blood coagulation present in our plasma. This is in inactive form. This is converted to active thrombin in presence of prothrombinase enzyme. So prothrombin is converted into active thrombin in presence of this prothrombinase enzyme, right? So now thrombin form here is again acting on fibrinogen, again inactive form present in our blood plasma. This inactive fibrinogen is converted into active fibrin, in presence of previously formed this thrombin. Inactive fibrinogen is converted into active fibrin in presence of previously formed thrombin, right? And this fibrin forms fibers or mesh of fibers in this way, a network of fibers in this way, in which the flowing blood containing blood cells gets entangled, and after entangle of this blood vessel, the bleeding stops or blood coagulation occur, and this is known as a clot. So at final, this clot is formed. Clear? So to complete all these steps, it needs about 2 to 8 minutes, and this 2 to 8 minute duration is known as clotting time, CT, clotting time. So it is very necessary to find out clotting time of any person because it differs from person to person prior to any medical surgery. Clear? So these are the steps involved in blood coagulation or clotting. Now it is represented in one tabular form in our book or on a specific structure like this way. So prior going to that chart, again we will revise. Blood coagulation or clotting means conversion of liquid blood into semi-solid jelly-like substance or blood. The steps involved in blood clottings are: it starts with contact of blood with any foreign surface. That surface may be extrinsic or intrinsic. That means inside the body or external to the body respectively. Both intrinsic and extrinsic processes involve blood clotting factors. These clotting factors release step by step or by cascade method. And these are about 12 in number. Total 12 in number. Roman 1st to Roman 12. Only Roman 6th is not in active use. What happens during clotting process? The interaction of all these factors form enzyme thrombin. Now, thromboplastin is released from platelets where the injury is there and help in formation of enzyme prothrombinase. What happens after formation of prothrombinase? This prothrombinase first of all inactivates heparin. Heparin is anticoagulant present in our body, in our blood. Then prothrombin is another substance present in blood in active form. It is one of the protein. It gets converted into active thrombin in presence of prothrombinase. Now previously this prothrombin is formed by this cascade method. Then fibrinogen is another inactive component, protein component present in our blood. It is then converted into active fibrin in presence of this previously formed thrombin. And finally, these fibers form one mesh network into which the flowing blood cells entangles and form a semi-solid jelly-like clot. And at that point, this blood clotting process complete. It needs about 2 to 8 minutes to complete all these steps known as clotting time or blood clotting time or CT. This CT is very much important while operating any kind of operation during surgery. So one must know that means their own clotting time, blood clotting time. So in our textbook, one chart is given about this blood coagulation, and that chart is in this way. You can draw that chart from textbook directly. The extrinsic pathway, intrinsic pathway, extrinsic pathway and intrinsic pathway. Under extrinsic pathway, the damage to tissue outside the blood vessel, it is carried out by damaged cells outside damage to tissue or cells outside the vessel, outside the blood vessel especially. Here damage to blood vessel directly, damage to blood vessel directly. Intrinsic, inside the body, and this is outside the body. Tissue release thromboplastin, just we have studied. blood platelets release thromboplastin. And in intrinsic pathway, cascade of clotting factors occurs. Cascade or step by step clotting factors are formed, and these cascade clotting factors, now previously there is an inactive factor 10th, especially inactive factor 10th. This activates both this cascade method and this thromboplastin activates factor 10th, and due to the activation, prothrombin is converted into thrombin, inactive prothrombin into active thrombin, and similarly fibrinogen is converted into fibrin due to this thrombin, and finally a blood clot is formed. Such kind of chart is given in our textbook. So remember that chart may be asked for 2 marks in examination. Extrinsic pathway occurs in damage to tissue outside the blood vessels, and intrinsic pathway occurs directly in the damage to blood vessels inside the body. Tissue cells, that means blood cells or thromboplastin is released. Here cascade clotting factors are released, and previously there was inactive factor 10th. This inactive factor 10th is activated, and this activated 10th factor now convert prothrombin into thrombin, then thrombin convert fibrinogen into fibrin, and finally a clot is formed. Right? So in that way, here we complete blood coagulation or blood clotting. Right? So now we complete all 3 types of blood cells: RBC, WBC, platelets, and finally the process blood coagulation. Previously we have also complete blood plasma, the composition of blood plasma, and here we complete the previous unit. Now we'll go to the next subunit, and that is known as heart. Remember, it is most important unit in our circulation. So sketch the diagrams previously of external internal structure of heart. External structure of heart includes ventral view, dorsal view, and internal structure of heart, that means the vertical section of heart. So 3 diagrams you have to draw in advance prior to teaching. Okay? So I will send you the notes along with this video. Complete that notes, rewrite that notes, solve the exercise, draw the diagrams, and study